Welcome to this session. In this session, I will try to explain how to find the Laplace transform of this signal in two different ways. So first method is we'll start from the scratch of Laplace transforms. Second one is we'll use Laplace transform of exponential signal directly to get the Laplace transform of cos omega t multiplied with u of t. So first method, cos omega t we can express it in exponential terms as cos omega t equals to e power j omega t plus e power minus j omega t divided by 2. Now the x of t becomes cos omega t is in exponential terms e power j omega t plus e power minus j omega t divided by 2 multiplied with signal u of t. So u of t is the unit step signal. So we know the amplitude of unit step signal is 1 when t is greater than or equal to 0 and its amplitude is 0 for t less than 0. So now we'll apply the Laplace transform on both sides to this expression. So apply Laplace transform on both sides. So that gives Laplace transform of x of t equals to, so we rearrange this equation as 1 by 2 Laplace transform of the first exponential term multiplied with u of t e power j omega t into u of t plus 1 by 2 Laplace transform of e power minus j omega t multiplied with u of t. Laplace transform of x of t is x of s equals to 1 by 2. So Laplace transform of this function. So here u of t is there. So that indicates the limits 0 to infinity. So we can write Laplace transform of this expression integral over 0 to infinity e power j omega t into e power minus st dt plus the second term 1 by 2 Laplace transform of this multiplied with u of t. Because of this u of t, so the integral limits becomes 0 to infinity e power minus j omega t multiplied with e power minus st dt. From this expression, so we'll try to note the region of convergence. So that is existence of Laplace transform for this complex exponential signal. As we know that the magnitude of e power j omega t is equals to 1 irrespective of the values of omega t. Even we are changing t value from 0 to infinity, the magnitude of this function will be same. So then the expression of this integral becomes integral 0 to infinity e power minus st dt. Now from this expression we can say this expression will be finite for the values of s greater than 0. So s represents real part of complex quantity, that is sigma. So we can also write sigma greater than, for the second term, so also we can write e power minus j omega t magnitude is 1 irrespective of the values of omega t. So then the expression is integral 0 to infinity e power minus st dt. So this expression is a exponentially decaying function. So this function will be finite if and only if s is greater than 0 or the real part of s, that is sigma, greater than 0. So this gives the region of convergence for this signal cos omega t multiplied with u of t. Now we continue the simplification of Laplace transform. So that is 1 by 2. So the first integral term becomes integral 0 to infinity e power minus of s minus j omega multiplied with t to dt plus second term 1 by 2 integral over 0 to infinity e power minus of s plus j omega multiplied with t dt. So from the above expression we write 1 by 2 is outside, and the first term becomes e power minus s minus j omega into t divided by minus of s minus j omega over the limits 0 to infinity, plus second term e power minus of s plus j omega into t divided by minus of s plus j omega over the limits 0 to infinity. Now we apply the limits to the function. So that gives us e power minus infinity minus e power 0 divided by minus of s minus j omega, plus the second term is also e power minus infinity because of upper limit is infinity, minus e power 0 divided by minus of s plus j omega, that equals to 1 by 2 0 minus 1 divided by minus of s minus j omega. So e power minus infinity value is 0, e power 0 is 1, plus the second term 0 minus 1 divided by minus of s plus j omega. That gives us 1 by 2. So minus 1 by minus of s minus j omega. This becomes 1 by s minus j omega, plus second term minus 1 by minus of this. So we will get 1 by s plus j omega, that equals to denominator is s minus j omega into s plus j omega. Numerator becomes s plus j omega plus s minus j omega. So the numerator have plus j omega minus j omega, they get cancelled. Then the expression becomes s plus s 2s divided by, so this is in the form of a minus b into a plus b. So that gives us a square minus b square. Then we write it as s square minus j square omega square. So 2 in the numerator and denominator become cancelled. Then the expression becomes s by s square. J square value is minus 1, minus of minus plus omega square. So this is x of s. Therefore, for the signal cos omega t multiplied with u of t, the Laplace transform is s by s square plus omega square, and ROC is s greater than 0. Now we will see the second method for finding Laplace transform for the signal x of t equals to cos omega t multiplied with u of t. Now x of t is, so we express cos omega t in terms of exponentials as e power j omega t plus e power minus j omega t divided by 2 multiplied with u of t. Now apply the Laplace transform on both sides. So 1 by 2 we write outside, Laplace transform of e power j omega t multiplied with u of t, and the second term is 1 by 2 Laplace transform of e power minus j omega t multiplied with u of t. So Laplace transform of complex exponential signal, that is e power j omega t multiplied with u of t. So this was already explained in the previous lecture. So from that we can directly write Laplace transform of e power j omega t multiplied with u of t equals to 1 by s minus j omega. Similarly, Laplace transform of e power minus j omega t multiplied with u of t is 1 by s plus j omega. So now this expression becomes 1 by 2. So here we can directly substitute the Laplace transform of it. So that is 1 by s minus j omega plus second term Laplace transform of this function is 1 by s plus j omega. Now we write 1 by 2 outside. So then the expression is 1 by s minus j omega plus 1 by s plus j omega. That gives us 1 by 2. The denominator becomes s minus j omega into s plus j omega. Numerator is s plus j omega plus s minus j omega. this plus j omega minus j omega get cancelled, and the numerator becomes s plus s 2s divided by s square minus j square omega square. 2 in the denominator and the numerator become cancelled. Then the expression becomes s by s square. So j square value is minus 1. So minus of minus plus omega square. So this is x of s. Therefore, for the signal cos omega t multiplied with u of t, Laplace transform is s by s square plus omega square, and ROC of signal is s greater than 0. So in this video, we have seen the Laplace transform of cos omega t multiplied with u of t in two methods and their ROC. Thank you.